Hello, everyone. So I'll be talking about workflow library for API development. But first, let me introduce myself. Hello. Hello. But first, let me introduce myself. Myself, Suryanshu Singh. I am a lead software engineer at Make My Trip, having almost 9 years of industry experience and having experience of 3 years in Golang. So moving on to the agenda, I'll be first defining what is an API workflow. Then we'll give you some use cases and examples. We'll deep dive into the architecture, followed by some of the key features of this workflow, and then how it is different from the currently existing workflows. So what is basically an API workflow? So it is a structured sequence of tasks or activities designed to achieve a specific outcome. Now, when a workflow is properly designed, it ensures that the task is done very effectively and efficiently, and the resources used are quite in an optimized way. Now, when I talk about workflow in a software industry, it can be a long-running process or a job. For example, in a food delivery system, what workflow basically happens when you order? So first, the order is placed, then the order is moved to the restaurant. The restaurant starts preparing the order, and then a delivery boy is assigned. A delivery guy picks up the order and delivers it. So these all steps come together to make it a workflow. Now, when all these steps happen under one API, we can call it as an API workflow. Now, let's see this with an example. Now, I searched for Clark Summit Jaipur Hotel on Make My Trip and went to the room page. So in this room page, if you that is not coming in the screenshot, on the top there is hotel details, okay? And here you can see we have the room details, we have all the room data, you can see the meal plans, cancellation policies, then we have rates, taxes, and offers, coupons, okay? So do you think all this data is coming from one service from the backend? No, right. There are multiple microservices involved to gather this data and power this UI. Now, if I look this page as a workflow, how that workflow will look like. So we can do a parallel call to get the hotel data. We can do a parallel call to get the room data. After that, a sequential call to get the room inventory. And in parallel, we can also get the meal plan data, followed by getting cancellation policies and rates in parallelly, and then apply offers and taxes, and finally merge all the data and send it to the UI. So if you see all these steps, this is basically what a workflow looks like. So if I have to write code for this, it will be something like this, where we are launching multiple Go routines to do things in parallel. Then within the third Go routine, we are again launching multiple Go routines to get the meal plans and the cancellation policies. So this code might look a little bit tidy here, but in real life, the code becomes quite cumbersome. It becomes quite difficult for a developer to understand this piece of code. Okay, so if I need to write this piece of code in a structured workflow manner, how it can be written? So it will look something like this, where all the steps are defined one by one. Now I will talk about one of the steps. I will zoom in one part. Okay, so if you see here, I have just given a name to a node, then given by the function, the task which it has to perform, and then there is a depends on of a string array, which means which task has to be finished so that this part can run. So this is one of the steps. Now, if I need to run this piece of code so that this runs similar to this one, I need to have a tool or a framework which can run this part of code as similar to the one in the left side. So how this can be done? So for this, we developed a workflow, we developed a framework. Now this framework is not currently open source. So I will guide you guys how you guys can prepare a framework similar to mine so that you can also implement this in your organization. And the code writing structure will be quite easy after that. So let's start with the architecture. So coming to the previous example, which I gave here. Now, what data structure does this resemble? Come again? Graph, yeah, correct, graph. So this is similar to a graph. Now, what does a graph has? A graph has a list of nodes and a graph, and within a node, there are references to the next nodes and previous nodes. Now I know many people will ask, okay, graph has edges also, man. But for the sake of simplicity, let's think that a node just has the references to next nodes and previous nodes. Now coming to the components of the workflow graph, which I designed. So it has a data store also on the graph level. So graph has the list of nodes and a data store. Now this data store is nothing like a real DB or a cache. It's just a map so that the nodes can interact to each other. The nodes can put the data in that data store or can read the data from that. So it's basically a data store for sharing the data between each nodes. And then I introduce the actor within a node. So actor is basically the core logic, the core method which it has to implement, which it will be performing to execute that task. So this is about the components, okay? So this is all about the graph and its component, but how does this graph runs? How the actor tasks of the graphs are executed? For this, let me start with a small story. So in parallel universe, there was a very intelligent manager, very time-saving, resourceful person named controller, okay? Now I felt like to have biryani one day. So I asked controller, okay, controller, I will give you the recipe. Can you prepare biryani for me? And I gave him the recipe. The recipe was to fetch the materials, prepare the rice, cook the chicken, and then mix the materials together so that the biryani can be created. Now, controller was an intelligent guy. He knew that this task cannot be done effectively by just one person. And controller had a pool of executors at his disposal. So for this task, he chose 4 executors. I will name them as Iden, Biden, Kaden, and Daden, okay? So this controller asked all his 4 executors to do the work. Now how the flow happened, I will explain this to you. So the controller first asked the first executor, hey Iden, do your work and let me know the next step as soon as you are done. Now Iden did his work, like he fetched the materials. He then informed the controller that, okay, now I have done the work. The next steps are to be chicken to be prepared and rice to be cooked. Okay, and then he also broadcasted the message, I have done my work. Now, controller received this message and he asked the other 2 executors, Biden and Kaden. He said the same things to both of them. Iden did your previous work and you have to cook the rice to Biden and let me know the next steps. And to Kaden, he said the same thing. Iden did the previous work, prepare the chicken, and let me know the next steps. Now Biden and Kaden first checked that, okay, who was the previous worker? So it was basically Iden. They checked if they have received message from him or not. And after receiving the message, they started doing their work, okay? So after some time, now as Biden only had to prepare the rice, so he was done with it. So he first completed his task and he said to the controller, hey controller, I have cooked the rice. Now, next step is to mix the chicken and rice. The controller receives this message, asked Daden, the 4th worker, that previous work was to be done by Biden and Kaden. If done, then mix the rice and chicken and you can go now. So Daden receives this message. Daden checks his messages. So he checks he has received the message from Biden, but not from Kaden. The Kaden is still preparing the chicken. So he patiently waits for the Kaden to prepare the chicken. Kaden is doing his best to prepare the chicken as fast as possible. Now, as soon as the cadence does his work, he again informs to the controller that I have finished the chicken. The next work is to mix the chicken and rice. And he also broadcasts the message. The controller sees that, okay, I have already assigned this work to Dayden. So he casually ignores it, whereas Dayden received this message, okay? So finally, after some time, what did happen? Dayden prepared the biryani, he sent it to the controller, okay, I have prepared the biryani. He also broadcasted the message, and then the biryani was prepared. So how did this look as a workflow? So the first step was, Aiden got the materials, Biden cooked the rice, Kaden got the chicken, and then Darren mixed those materials to prepare the biryani. So if I relate to this in the workflow, how basically the controllers and executors interacted with each other. Now there was a graph. The graph was passed to the controller. The controller had to execute all the nodes, so he created executor for all the nodes, okay, and assigned channels to them. Now the executor executed each of the nodes one by one until unless he received the message from the previous executor, and the actor is basically the function which has to be performed, the task which has to be performed. So this was the workflow execution. Now let's talk about how did the workers were communicating with each other. How did the flow went from one executor to another executor? So for this, I used one of the most nice feature of Go, that was channels. So for each executor, there were 3 channels. There was a notifier channel list, there was an output channel, and there was a broadcast channel. Now in the notifier channel list, basically a worker used to check if it has to wait for any work to be finished. That is for notifier channel list. Through output channel, it used to send signal to the controller, and for the broadcast channel, it used to send it to the other workers that the work has been finished. So the first step here was controller created the executor, assigned the channel, and launches the executor in a separate Go routine. So the worker goes at a separate path in a separate Go routine, okay? Then in the second step, executor check if it has to wait for someone, if it has received the message. The third step used to start, that is the node execution is started, the task execution is started. At the fourth step, after the task completion, it used to send a signal to the controller that, okay, next work is this one, next node is this one, you can start with the next work, and then finally the broadcast channel was closed. So this is how the executors were communicating with each other. Now, if you see the graph as a whole, how the execution took place. So there was a controller. We have 4 nodes here, and a data store. The data store is common across all the nodes. The controller created worker for node A. It checked that it not has to wait for anyone, so it started the work. It fetched some data from the data store, or it put some data into the data store. Then it sent to the output channel that node B and C are ready for execution. Node B and node C workers were assigned, and the message from node A was sent to node B and node C. So those messages were received at the node B and node C end, and then node B and node C started their execution. Node B finished the execution first. He put some data into the data store. He read some data from the data store. Then finally, he sent that the node D is also ready for execution. But node D received the message from node B, but it still has not received from node C, so it will wait. It will wait for the work to be finished at node C level also. There are 2 channels there, B and C. It has to wait, then only it will start. So finally, node C completes its execution, and it also sends that node D is ready. But controller ignores that since it already has been assigned. Now finally, the message is sent from node C to node D, and node D starts its execution. Node D finally sends the signal that the work has been completed. There are no next nodes, and finally it's done. So this is how the workflow execution took place as a whole. Now, if I talk about what some of the key features of this workflow, what did this workflow provided us extra benefit? How? So there was internal handling of error and panic. I will tell you how. If you see here, there are 3 parallel calls happening, okay? Now, if in the second parallel call, if I am not able to get the room data, if I'm not able to fetch the room data, does it make sense to get the room inventory? Or does it make sense in the third parallel call to get all the cancellation policy and rates if I'm not getting the room only? It doesn't make sense, right? So how I can stop the workflow? If I go in the traditional way, I will have to use a lot of channels to transfer data to give a signal that we have to stop now because one of the API failed. But in this workflow, it becomes quite simple. How? We can just have a graph state at the graph level. We can set the graph state to error or panic state. And then the graph, each node before its execution can check whether what is the graph state. And even in parallel calls, they can stop their execution from unnecessary calls to happening. So this is one of the very good feature. Then if I talk about another feature, we introduced rollback handling also. So I was talking about get calls till now, but suppose if there is, we are doing multiple update calls or create calls. So if in that scenario, if one of the update calls fails, we need to roll back the previous calls also, or other parallel calls also. So how this can be done in a very efficient way? So within a node, as I told you in the very beginning, we have an actor. We can have a rollback actor also in the node. And we can set the graph state to roll back and start the graph again in rollback state. And in this scenario, the rollback actor will be executed, and thus the rollback tasks will be executed. Coming to the next, some other features. So concurrency and performance. You don't need to think about concurrency and performance here. It's already taken care of. Everything is executed in parallelly. Flexibility. The nodes here are totally independent things. These are like plug-in playable nodes. You can use them in any other workflow. So suppose if you are getting the room data, you need room to get the room data in some other node also. You can just use that node in any other workflow, and you don't need to code much there. Okay, the minimal learning curve. So the developers here found it very easy. It was this workflow steps were quite easy to be defined, and so the developers found it very easy. This simplified my code base also. We now have a simple step to write every API which does a number of calls. And then the next feature is different actor types. I introduced one more thing, different actor types. So suppose the task which has to be done, it can be a gRPC call, it can be a HTTP call, or it can be a database call. Now, suppose I take the example of database call. What basically it happens there? We provide a query, and then we create a connection, we do a call, and then get the data. Now, all this logic can be abstracted. We can just provide the query to a database actor, and rest things can be taken care by the database actor itself. So for that, we need to have one more extra in the node configuration, which I was defining in the very start. We can have an actor type also there, and then more abstraction can be done at this. And this graph can internally handle the logs and metrics. Now, coming to the next slide, how it is different from existing workflows which are available. Now, if you search on Google, what are the existing workflows, you will get a lot of examples, like Cadence by Uber, Netflix Conductor, and Temporal. These all are written by great engineers. So there must be something good here. But why I have written something of my own? Because these workflows are designed to handle complex scenarios with robust state management. I am quite sure you guys, some of the few guys here must be using these workflows. But these workflows are used for running tasks which run for extended periods of time. No workflow I have seen which runs for only within an API. So what workflow is designed here is used for one API. Okay, these workflows do also require data storage to maintain their state, and also for other operations. But our use case is to have minimum latency as possible, because we are working within an API. So these workflows did not provide the use case which I wanted. So that's why we went ahead with creating a framework of our own. So that's my time, guys. Thank you. You can scan the QR for my LinkedIn. Thank you.
Questions for Suryanshu?
Hello. So we're using Gopher proto-actor framework in Go to implement the same workflows in one of the business core. What are your thoughts on proto-actor framework, or are there any other frameworks in the open source as proto-actor which can be modified to implement the same workflow that you're talking about? Because we have implemented that same logic.
Can you just name that?
Proto-actor.
Proto-actor.
Yeah.
Okay.
It also works on the actor model, which you are talking about.
Yeah, I looked for that. I was, the name which you are calling, I was not able to find that actually. I'm not sure, to be frank. But I will have a look into that if that does the similar job. But that if it does similar job, then that's fine. Yeah, I will have a look into that. Yes.
I think there was one more question.
Yeah, from that guy.
Hey, my name is Divyanshu. So I could not understand why the individual nodes need to tell the controller that they have finished the job when they can actually they are actually communicating to the downstream nodes. If the dependency graph is resolved, the controller could simply just kick off the execution, and then the rest of the nodes can communicate their dependent nodes.
Yeah.
So why there was a need for?
Yeah. So this was required because a worker needs to be created, or an executor needs to be created in beforehand, so that we do not waste any time in the channel creation. Also, it becomes difficult for a node itself to assign, if suppose if a node finishes and it tells the other node that you start your execution, okay? Now, the node will have to have its channel, okay? So that it can send it to the other channels also. It needs to have a channel to send it to the controller also. If I went through this approach, the code was getting messy there. It was very getting difficult to assign all the channels at the node level, at the node itself, assigning the channels itself. So there was a controller whose job was to basically create an executor or a worker, and the controller was basically assigning them the channels. The controller was the head. He was seeing that, okay, he is the node, he has references to these nodes, so assign these channels to it so that it can broadcast messages to these nodes. So that's why we went ahead with this approach.
Just follow up on that. So when does the controller create the worker nodes?
So the nodes used to send signal to the controller.
Yeah.
If you see, as soon as the nodes finished its work, it used to send a signal, okay, that the next nodes are these. And the controller created executors for those and assigned the channels also. Okay, so sometimes it used to happen beforehand also. Like if you see in the example of node D, the last node execution, it was done beforehand only, before the C finished its work. So C was the time taking there. Suppose if C would have finished and then we start creating the worker, then it would have delayed a little bit more.
So, like, is this per API call?
Yeah, this is basically a API call. Within an API call, everything will happen.
So does this not add a overhead of creation?
See, overhead of creation, we looked into the latency part also. We had existing APIs. We moved this part of code to new API with the same logic, and we did not observe much latency there, to be frank. The latency only introduced was creating the channels, assigning the channels to each of them, which was like 3 to 4% maximum. More latency was there than the previous one. But the code base simplification was so much that even with 3-4 more latency, we went ahead with this approach.
Thank you.
Yeah.
I have time for a last question, maybe, or last 2 questions. Could you please pass the mic behind there?
Yeah, hi, this is Sachin. We use workflow a lot, And my question is like, what do you guys do to like, have a monitoring in place if something goes wrong with this kind of systems, So,
Yeah. So for that, we introduced a rollback thing also, right? You mean to say that if in the update calls, if something fails?
No, not rollback.
No.
Monitoring. Your
Yeah,
workflow.
Okay.
I mean, suppose you have like a workflow which has 4 tasks, suppose A, B, C, D,
Okay.
and like B and C is running in parallel, and suppose C fails, right? And I want to understand what exactly happened, in terms of traceability and, log and everything.
Got it. So when you are creating the controller, first you will create a controller, then you will pass the graph to it. Now while creating the controller, you need to pass the instance of logger, the instance of metric push, okay, and the controller will internally take care. So when there is, suppose if there is any failure, you will write code to push a metric. Now you will not need the instance there itself, because the instance will be passed by the controller through the node, and then the instance will be there. You just need to do a like instance metric push dot instance, and you will push the metric there.
But to connect the dots, are you guys using some kind of tracer ID or something like, what happened when and why, like?
Not kind of a tracer. We use another library for metric push. We use for logger, we use JAP logger, and in the same like for logging, if there is any issue, if it feels like if there is any panic or something, we need to push a metric. Or in the case of API calls, we need to push metric that how much time it is taking. So we have that handled. As I told you, metric package name I cannot remember right now, metric package name, but we use a standard metric push library there.
Okay, thank you.